Hello guys, how you going? This is Eddie the Magic Monk. One of my subscribers requested a quadratics problem solving video, so I put this one up, modified one of the questions that I have seen before, and hopefully you will enjoy this question. So let's explain what this question is. So here I have a Cartesian plane, here's the y-axis, here is the x-axis, and the question is the diagram below contains a graph of y equals 0.5 x squared. So x squared, that's the notation for x squared. I'll just put that there. That's what that means. And other unknown functions which are obtained by transforming the original function. So here's the original function, and we want to know what the equation of these two functions are. So this is a function and this is a function, and we want to know the equations of these other functions. And these are all based on our original function, right? So basically you take this function and you modify it a little bit and you can find out what these other functions are. So have a go at it and come back when you're done. Okay, so how do we transform a function? Well, if you remember, the turning point form of quadratic equations is y equals a bracket x minus b squared plus c, where b is the horizontal translation and C is the vertical translation. Okay, so if we want to move this graph to the right, okay, so let's say we want to, this is our original graph, okay, and let's say we want to move it over here. So we're moving it to the right. So the first thing we'll do is we will go f of x equals 0.5 bracket x minus 2 squared. That will move it to the right. Okay. And then we move it 2 units down. So we move it 2 units to the right. So let's write that down. 2 units to the right. And then we move it 2 units down. So to shift it down, we would go f of x equals 0.5 bracket x minus 2 squared minus 2. That will move it 2 units down and get to here, right? Because the distance from here to here is 2. So we've moved it from our original turning point, which is at 0, 0. We move it to the right 2 units, and then we move it down 2 units. Okay, so now g of x has the equation 0.5 bracket x minus 2 squared minus 2. Okay, now remember we have to set a domain, right? Because notice how this line stops at this point and at this point. So the domain of g of x is where x is between 0 and 4. Right, you have to say that because this line doesn't go beyond x is 0 and x equals 4. Okay, let's now have a look at what happens with a of x, which is this other equation. Okay, so from the original position, what we do is we move it 4 units to the right. So I'm just going to get another color. So from the original position 0, 0, I move it 4 units to the right. This is x equals 4. So it'll be a of x equals 0.5 bracket x minus 4 squared. And then I move it 4 units up. So the turning point is 4 units up. So I move it 4 units up plus 4. But then I reflect it, because 4 units up would be here, but I reflect it upside down. So then it turns into this. So the reflection is A. A turns into negative A. So then it becomes negative 0.5. Now what about the domain of the new equation? The domain of the new equation is between x is 2 to x equals 6, right? Because that's where the line stops. So then the answer is where x is between 2 and 6. Okay, so that's the answer. Okay, that's the answer. We got g of x, which is this graph, and we got a of x, which is this graph. Okay, thanks for watching.